Here we have a function f from the set A to the set B. That's all the information for that is right here. You have the set A, the set B, and we have a function f going from A to B. F sends 1 to 5, 2 to 6, 3 to 6, and 4 to 8. And we also have all the information for a function g. G goes from B to C. All the information is right here. Here's the set B, here's the set C. And G sends 5 to 9, 6 to 10, 7 to 10, and 8 to 12. So we have F from A to B, and G from B to C. And now the composition is going to go from, the composition is going to go from A to C. And the way we write this is G composed with F. Now this might seem backwards. You might be saying, well, why is it G composed with F and not F composed with G? We start with F and then go to G. And that's a good question. So why is that? Okay, so this is really a computational thing. So the way that it's supposed to be is G composed with F is from A to C. That's the correct way to do it. Now let's just say, for the sake of argument, that we want to look at F composed with G from A to C, because this is the way that many students think, hey, it should be that way because F comes first. And so let's see, well, what would F composed with G of 1 be? Remember, F composed with G, this is F of G of 1. Well, so what would that be? Notice that G doesn't even, the domain of G is 5, 6, and 7. 1 isn't even in the domain of G. So this way doesn't make sense. It just doesn't make sense. So that's why we don't do it that way. We do it the way that makes sense. We have G composed with F. This is because G composed with F of 1 is G of F of 1. Now what's F of 1? F of 1 is 5. So we have G of 5. And G of 5, let's see, that's 9. And so this is why we write it in the reverse order when we write this, as reverse of your intuition.